Partial fractions 5, irreducible quadratic factors, and we're going to look at some worked examples. And you'll recall from a few videos ago, this is about for every irreducible quadratic factor in the denominator, we see that there will be a factor in the form of dx plus e over ax squared plus bx plus c in the answer. And in the light blue there, this is the form that appeared, which shows case 3, because this is case 3. This is one of the manifestations of case 3. Okay, so that was done in a previous video. It can also be seen perhaps like this too, because you don't always get ax plus b up there. Okay, so we could write f of x provided the degree of f of x is less than what is on the denominator. So whatever the denominator expands out to, f of x must have a lower degree. That was something from a previous video. So that might be something like, remember, don't get hung up too much with the symbols. It's the form that we're looking at, and that's true for all of these videos. Okay, something like that. Okay, and so we might have the same as above there. So you'll have I'm just copying down the line above. Okay. So the only problem I have with what's in the light blue, which you'll see in some books, and it's not wrong, but what if you're presented with something other than ax plus b? Hey, you may only ever be presented with that, but you might be presented with, say, a quadratic on the top. Okay, so just let you know that we can write f of x there. Okay, so we need to be a little bit open with these. And just to show you that, what if we got something like this? There's a quadratic on the denominator, so let's write out the partial fraction form. So we have x take 2, we've got bx plus c, big C, alright, and now that, remember, has to be an irreducible quadratic as explained earlier in earlier video, and it is. Okay, test it out for yourself, or go back to an earlier bit of work. Using the same steps as in all the previous videos, we can get that equation there, and we let x equal 2. Okay, and we'll get 21 equals 7a, and thus the identity of a is known, a is 3. Okay, so what I'm doing now is I'm expanding out everything. Okay, this is not the only way to do it, but this is the way we're going to do it. So I've expanded out the first bit, bx plus cx minus 2, expanding that now. So we have bx squared minus 2bx plus cx minus 2c. Going to group like terms so we can equate the terms together, equate coefficients. So we will group them together, and up our sleeve we have this superpower that we know that a equals 3, and that will make life easier. You could sub 3 in right now if you like, or you can just wait till, do the good bit last. It's a bit like eating a meal and saving your favourite bit to last. Eat all the bits you don't really like and then the favourite bit at the end. Perhaps it's not that good. So I've equated the red, orange and yellow according to the coefficients of x squared, x and the constants, and now we're going to sub in 3 in each case, and then get some handy equations. So we have 1 equals, because remember a equals 3, so in fact we know b as well now. B equals -2. Okay, and we know a and b, so in fact the orange equation will come out pretty quickly too. So we have 6 equals 3 take 2 lots of negative 2 plus c. So that means that 6 equals, if we have 3 take 2 times negative 2, that's 3 take negative 4, so it's 3 plus 4, it's 7. And so we know that c equals negative 1. And we basically, do we even need the last equation? I guess we can use it to check. So does it make a true statement? 3 minus 2 times negative 1, does that equal 5? Well, that's 3 minus negative 2, 3 plus 2 equals 5. It's a true statement. Yeehaw. So we can write our answer of a is 3, so it's 3 over x minus 2. And we have b is negative 2, so we have negative 2, just following that form from earlier on, negative 2x minus 1 over the quadratic. And if you like, you can write it a little more elegantly like this. Take the factor of negative 1 out. Okay, we've resolved it as partial fractions. Last example, and this one is more difficult. Now, as well, it's kind of an extension from case 3. And I've deliberately swapped the two terms in the sum in the partial fraction around, just to show you that you will see variations on this, but just keep your wits about you, okay? This one does have a situation where we have an irreducible quadratic, but it doesn't necessarily look like it at first, okay? It's not the difference of 2 squares because there's a plus sign there, you can see. So let's have a look at this one there. This one is more demanding, right? It is still case 3, however. Okay, so you can see a case of that there in this example. And so on the denominator, looking at the denominator now, that's where we need to do a bit of work. Think about your factor theorem, which tends to mean we're thinking about x minus alpha, okay? And we want alpha such that f of alpha equals 0. Okay, so we have, if we try, to cut a long story short, you remember all our earlier work on the factor theorem over the last few units, but to keep the video short, f of negative 2 is negative 2 cubed, etc. So you get negative 8 plus 8 minus 8 plus 8 equals 0. So x minus negative 2 is a factor, or we would say x plus 2 is a factor, okay? Now either by factorizing the quadratic by inspection, because you can see there's pairs of factors of x plus 2, x plus 2. So by inspection works, or you could try polynomial division and divide the x plus 2 into the cubic. It's not that hard, and this one comes out pretty quickly. Either way, that's not the focus of the video. You'll actually get the other factor is, well, I'll put it up where it's supposed to go, x squared plus 4. So we rewrite that denominator then as, well, let's write the whole fraction, and the denominator is rewritten in the form that we want. So we have the factor x plus 2, and we have the other factor, which is an irreducible quadratic. Go try and solve that equal to 0. You won't be able to do it. There's no real solutions there. Try it. Pause the video and try it. And basically that's got to equal that form written above there. That is a quadratic. Don't worry about the middle term. Okay, middle term, the coefficient is 0. Alright, so just from the form at the beginning of example 2 we're using there. Using the steps we've been using in all the videos, we get to the point where we can equate the numerators, and we'll need to do some expanding and a bit of work with simultaneous equations here, which I'm going to cut briefly, you may need to pause the video at times and work out the missing steps. But it's certainly nothing that you haven't done before. Okay, so you could use the 3 simultaneous equations for this, but the equations are of very simple nature. Expanding and collecting like terms, we get that, so we're going to equate things, and it will involve some equations. These are the equations I refer to. I'm not going to show the solution to this. You should know how to do that. It'll take a few steps. The steps are simple, however. Perhaps you'd like to pause the video and see if you can do that and match the final answers I'm about to put up. So pause the video and see if you can do the solving bit now. When you do that, you get A equals 2, B equals 3, and C equals -1. So the final answer, expressed as partial fractions, case 3, 2x plus 3 over x squared plus 4 minus 1 over x plus 2. This was case 3.